What is the most important human fossil ever found? That's a big question. It's like asking what's the most important invention. Is it the wheel? Is it the printing press? Is it the microchip? The answer depends on what you mean by important. Some fossils are important because they are the oldest. Some are important because they are incredibly complete. And some are important because they completely changed our understanding of our own story. There are many contenders for the title. There's the Tong child, the first of its kind ever found in Africa, which pointed to the real cradle of humanity when everyone else was looking in Asia. There's Turkana a stunningly complete skeleton of a young Homo erectus who showed us when our ancestors developed modern body proportions. There's Artie, a fossil older than Lucy, who gave us a glimpse of an even earlier way of walking upright. All of them are crucial pieces of the puzzle, but if you have to choose just one, the one that had the biggest impact, the one that turned our origin story on its head, it has to be Lucy. Her official name is AL 288 to 1, but the world knows her as Lucy. She is a 3.2 million year old skeleton of a species called Australopithecus afarensis. And her discovery in 1974 didn't just add a new branch to our family tree, it forced us to redraw the entire tree from the trunk up. To understand why she's so important, you have to understand what scientists thought before her. The prevailing idea about human evolution was a simple, logical story. It went something like this. Our ape-like ancestors started to get smarter. Their brains grew bigger. With bigger brains, they learned to make and use tools. To use these tools effectively, they needed their hands free. So, they started walking on two legs. Brains first, bipedalism second. It made perfect sense. It was a neat, tidy package. And then, Lucy came along and ripped that package to shreds. The story of her discovery is almost as famous as the fossil itself. It was November 24th, 1974, in the hot, dry landscape of Hadar, Ethiopia. A paleoanthropologist named Donald Johansen and his student Tom Gray were surveying a remote gully. They had been working for weeks with little to show for it. The day was hot, and they decided to head back to their Land Rover. But Johansen had a hunch. He suggested they take a different route back, through a gully they had searched before. For a long time they found nothing. Then Johansen spotted a small piece of bone on the ground. It was a fragment of an arm bone, a hominin arm bone. He recognized it instantly. He looked up the slope and saw more bone fragments eroding out of the sediment. A piece of a skull, a thigh bone, ribs, a pelvis. They knew this was something special. This wasn't just a few scattered teeth or a jaw fragment. This was a skeleton. A single individual. That night, the camp was filled with excitement. A cassette tape was playing the Beatles' song Lucy in the Sky with Diamonds over and over again. At some point during the celebration, the fossil skeleton got its name, Lucy. Over the next few weeks, the team painstakingly collected hundreds of fragments of bone. In the end, they had about 40% of a single skeleton. 40% might not sound like much, but for a fossil that old, it was a miracle. Usually, you find a piece of a jaw, a few teeth, maybe a leg bone if you're lucky. A partial skeleton allows you to see how the different parts of the body work together. It lets you reconstruct the whole animal. And when they reconstructed Lucy, she told them a story that no one was expecting. First, they looked at her size. She was tiny. She stood only about 3.5 feet tall and probably weighed around 60 pounds. She was a fully grown adult, which they could tell from her wisdom teeth and the fused bones in her skeleton. So she belonged to a species of very small hominins, and they looked at her head. Or what little they had of it, the skull fragments showed that her brain was small. It was about the size of a chimpanzee's brain. There was nothing special about it. There was no sign of the big-brained intelligence that was supposed to have driven human evolution. According to the old theory, a creature with a brain this small should still be walking on all fours, living in the trees. But Lucy wasn't. The most important parts of her skeleton were from the waist down. Her pelvis, her leg bones, and her knee joint told a clear and undeniable story. Lucy walked on two legs. Her pelvis was short and bowl-shaped, much more like a modern human's than a chimpanzee's. A chimp's pelvis is long and narrow, built for climbing and knuckle walking. A bowl-shaped pelvis is a hallmark of bipedalism. It supports the internal organs and provides attachment points for the large gluteal muscles that keep us stable when we walk. As Lucy had it. Her femur, or thigh bone, also told the tale. It angled inward from her hip to her knee. This is called a valgus knee. It's a critical adaptation for walking upright. It brings your knees and feet directly under your body's center of gravity. This allows you to balance on one leg at a time as you walk without toppling over. Apes don't have this. Their femurs run straight down from the hip. Lucy's angled femur was proof that she walked like us. The knee joint itself sealed the deal. The end of the femur that forms the knee joint had a prominent lip to prevent the kneecap from dislocating during walking. This is another feature found in humans, but not in apes. So, here was the evidence, laid out in bone. A creature with a chimp-sized brain was walking upright on two legs 3.2 million years ago. The old theory was dead. Brains did not come first. Bipedalism did. The first major step on the road to becoming human wasn't about thinking. It was about moving. This was a revolutionary idea. It changed everything. It meant that the very thing that we thought made us human, our intelligence, was not the original driving force. Instead, it was our strange way of getting around. Walking on two legs freed the hands. But it didn't free them for tool use, at least not at first. The first stone tools don't appear in the archaeological record until hundreds of thousands of years after Lucy. So why did her species start walking upright? We still don't know for sure. Maybe it was to see over tall grass in the savannah. Maybe it was to carry food back to a home base. Maybe it was a more efficient way to travel long distances as the climate changed and forests shrank. Whatever the reason, Lucy proved that bipedalism was the foundational adaptation of our lineage. It was the split from the other apes. Everything else, big brains, tool use, language came later. Lucy put our evolutionary story in the right order. But that's not the only thing that makes her so important. Lucy also showed us what a transitional fossil really looks like. People sometimes imagine a missing link as some kind of perfect halfway point between an ape and a human. That's not how evolution works. Evolution is messy. It tinkers with existing parts. Lucy is a perfect example of this. She is a mosaic of old and new traits. From the waist down, she looks surprisingly modern. Her hips and legs are clearly adapted for walking, but from the waist up, she is much more ape-like. She had long arms and relatively short legs, a bit like a chimpanzee. Her finger and toe bones were long and curved. This suggests that while she walked on the ground, she probably still spent a lot of time in the trees. Maybe she slept in trees at night to stay safe from predators. Maybe she climbed them to find food. She wasn't a human trapped in an ape's body. She was something unique, a creature perfectly adapted to her world, a world that was part woodland, part savanna. She could move efficiently on the ground, but could also retreat to the safety of the trees. She wasn't a clumsy, halfway version of anything. She was a successful species that existed for almost 1 million years. She shows us that evolution doesn't move in a straight line towards a predetermined goal. It's a process of adaptation to a changing environment. Lucy's importance was cemented by other discoveries. Nearby, scientists found the remains of more than a dozen individuals of her species who all died together, possibly in a flash flood. This group, known as the First Family, showed us that Lucy wasn't a one-off. She belonged to a thriving population, and in Tanzania, another paleontologist, Mary Leakey, discovered a set of fossilized footprints at a place called Laetoli. The footprints were 3.6 million years old. They were made by 2 or 3 hominins walking side by side through wet volcanic ash. The prints clearly show a modern human-like stride, with a heel strike and a toe off. They were almost certainly made by members of Lucy's species. They are a snapshot in time, a ghost of a walk taken millions of years ago, providing powerful, independent evidence that creatures like Lucy were already striding across the African landscape. Of course, other fossils have challenged and refined the story Lucy told us. The discovery of Australopithecus ramidus, or Artie, pushed the origins of bipedalism back even further, to 4.4 million years ago. Artie was also a mosaic creature, but she was even more primitive than Lucy. She had a grasping big toe, like an ape, suggesting she was still very much at home in the trees. Her form of bipedalism was different, perhaps less efficient than Lucy's. Artie is incredibly important. She gave us a look at what came before Australopithecus, but her skeleton was badly crushed and required a huge amount of digital reconstruction. The interpretation of how she moved is still debated among scientists. Lucy, in contrast, presents a clearer, more undeniable case for well-established bipedalism. Artie added a prequel to the story, but Lucy wrote the first chapter. Then there is Turkana Boy, the nearly complete skeleton of a Homo erectus boy who lived about 1.5 million years ago. He is a profoundly important fossil. He shows the next major shift in our evolution. He was tall and slender, with long legs and short arms, a body built for running and walking long distances. His proportions are almost identical to ours, and his brain was much bigger than Lucy's. He represents the emergence of our own genus Homo. He tells us about a later crucial chapter in our evolution, the one that led directly to us. But the questions he answers are different. We already knew that our ancestors got taller and smarter. Turkana showed us when and how in stunning detail. Lucy, on the other hand, answered a more fundamental question: what was the very first step? She changed the entire framework. The Tong child, found in South Africa in 1924, deserves special mention. This was the fossil that first put our origins in Africa. At the time, most scientists believed humans evolved in Asia. Raymond Dart, who discovered the fossil, correctly identified it as a bipedal ape, a human ancestor. He was ridiculed for years. The scientific establishment was not ready to accept Africa as our homeland, or that a small-brained creature could be our ancestor. The Tong child was the first crack in the old dogma, but it was the skull of a child, and skulls change a lot as they grow. It was harder to make a definitive case. It took decades for Dart's ideas to be accepted. Lucy, as a partial adult skeleton, provided the solid, undeniable evidence that proved Dart had been right all along. She was the confirmation. So what is Lucy's ultimate legacy? Why does she stand out above all others? Her importance is threefold. First, she proved with clear anatomical evidence that bipedalism came before big brains. This single fact reshaped our entire understanding of the sequence of human evolution. It set the agenda for paleoanthropology for decades to come. Scientists stopped looking for the big-brained ape and started looking for the upright ape. This was a paradigm shift. Second, she gave us a tangible image of a transitional ancestor. She wasn't a monster or a missing link. She was a small female creature, a blend of old and new, perfectly suited to her environment. She makes the abstract concept of human evolution real. You can look at a reconstruction of her skeleton and see the ape in her long arms and the human in her pelvis and knees. She embodies the process of evolution. Third, and this might be just as important as the science, is her cultural impact. Lucy became a celebrity. She has a name, she has a story, she captured the public imagination in a way no other fossil has. She became an ambassador for human evolution. Millions of people who have never heard of Homo erectus or Australopithecus have heard of Lucy. She is the fossil that connects us, in a very direct and personal way, to our deep African past. She is our most famous ancestor. That fame is not just a trivial detail. It matters because it makes science accessible. It gives people a character to root for in the grand story of our origins. Her discovery wasn't just a win for a small group of scientists. It was a discovery for all of humanity. It gave us a new and more accurate story of ourselves. So while other fossils may be older or more complete or represent a species more directly related to us, none had the seismic impact of Lucy. She was the right fossil found at the right time. She answered one of the biggest questions about our past and overturned a century of incorrect assumptions. She gave us a new creation myth, one based on evidence etched in bone. A myth where the first step on the path to humanity wasn't taken in the mind, but with the feet. For that reason, AL 288-1, the small hominin from Hadar, remains the most important human fossil ever found.